Alright, here we go with the second part of this review video on section 9.1, which is looking at circles and regular polygons. Right now we are going to be focusing on the regular polygons part. Remember that a regular means all sides and angles are congruent. That's the key thing that we're looking at. And we have this polygons just means that we're looking at multiple sided shape. Now in your book it breaks it down in terms of an apothem, and looking at that piece I'm actually going to look at it slightly different. So let's start with the shape that they give us here. We're looking at a hexagon. That looks pretty close to regular there. So I'm going to take this hexagon and try to break it up into the pieces that we need. And in fact, you know what, let's redraw that. Take this one off and put a new one on. The inside clear. Here we go. Okay, so when I'm looking at this, I notice that if I were to draw these diagonals across here, this would actually split up into 6 equilateral triangles. Now if this was truly regular, those would all be very equilateral triangles. That's just what happens with regular polygons. So now as I'm trying to look at this piece, I notice that this is 60 and 60 and 60. And with each triangle, if I could just find one of them, if I find the area of one, I can make all 6 of them. So take the area of 1 times 6, and then that gives me the whole shape here. So if there's 1, 2, 3, 4, 5, 6 of them, I really just need one. So let's try to make just the area of 1 and figure out what that would be. So the area of one equilateral triangle, well, the information that they give us is very important. Notice that they say it has an apothem 9 yards. Well, that's kind of helpful there, but if this was 9, then I want to figure out what the other stuff would be. So what they say when this is a height, or the apothem, that's really the height of one of these triangles. So this height is 9. And I know if this is a 30, 60, 90 triangle, because it's part of a hexagon split into 6 of them, then I can figure out the other 2 sides. Well, this side would be my side that represents x root 3. This side here is 2x, and this side is x. So let's see if I can figure out what x is. If x root 3 equals 9, divide each one by square root of 3, then I know that x equals 9 over square root of 3. Now, if I wanted to try and rationalize the denominator, I don't have to, but I could. I would get 9 root 3 over 3, and that reduces to just 3 root 3. So that would be our x value. So that means this x right here is 3 root 3. That's what they came up with as well. That also means that this side right here, or the whole side in itself, is 6 root 3. Why does that matter? Because it's asking us to find the area of a, well, if we're trying to find the perimeter, we would want to know that each side as well. Well, if I want to find the area of just one of these triangles, the area of a triangle equals 1/2 the base times the height. Well, let's look at this triangle here. The base is 6 root 3, and the height is 9. That was actually given to us in the beginning. So the area then is this value. Well, if we reduce the 2 and the 6, we get 3 times root 3 times 9. Well, I can multiply the 3 and the 9 and not have to deal with the root 3 quite yet. So then 3 times 9 would be 27 times the square root of 3. Now the trick is that that's the area of one triangle. I want to know what the area of 6 of them is, because I have 6 of these triangles put together to make that hexagon. The area of 6 is going to be 6 times 27 times the square root of 3. And if I look up here, that would actually give me this number, 162. So that equals 162 times the square root of 3 yards squared. To find the actual approximation, that would be up here, that's 280.6 yards squared. Now let's apply this same method to a few other shapes, starting with a regular pentagon. Now, a pentagon is probably easier for me to draw than you. I apologize for that. I know you don't have a tool that helps you draw a regular pentagon, but let's go ahead and see what we can do with it. So the first step is to try and split this up into triangles. Well, let's see if we can try and split it evenly. I know that each one's going to be a little bit different. That's close enough. We know that each side length is going to be 10. So I know this is 10, this is 10, this is 10, this is 10, and 10. And it's asking me for the area. Well, if I can find just one of them, then I can multiply that by 5, and that gives me all the triangles. So let's look at one of these triangles in particular and how it would be split up. So looking at these shapes, we got a triangle. This one's a little bit wider than the other one. Now the cool thing is that if you look at this inside piece right here, that's 360 degrees. So this right here is going to be 1/5 of that because there's 5 of them. Well, 360 degrees divided by 5, 5 goes into that 72 times. That means this is 72 degrees. Then I can look at these two pieces here, and I can figure out those because they're the same. These are the same all the way around. So I know this is 72. I know the total is going to be 180. So if I have, let's call this, I don't know, A. Well, actually, let's call it X. And this will be X. Then 2X plus 72 equals 180. Subtract 72 from each side. And then we get 2X equals 180 minus 72 is just 108. Divide that by 2. To reduce it, we got X equals 54. So that means that this is 54 degrees and this is also 54 degrees. So in order to find this height, I need to figure out something to do with this length here. I'll color that red. And this length here. Color this one blue. I have to think back to SOHCAHTOA. So if I'm knowing SOHCAHTOA, this tangent one is probably the one that's going to help me because I have an opposite and adjacent compared to that 54 degrees there. That tells me that tangent of 54 degrees is equal to the opposite, which is my height, over this adjacent. I know what that adjacent is because the whole thing is 10, so that means that half of it is going to be 5. So that means that 5 times tangent of 54 degrees equals h. Well, if I have a calculator, that would really help. So I'm going to pause the video, grab my calculator, and then bring us back here. Alright, coming back here, we were looking at this calculation here, 5 tangent, 54 degrees. So we're going to use a calculator. I have my calculator here on the other screen. And I'm just going to multiply this. We got 5 times tangent of 54. Let's see what that equals. It equals 6.88. I'm going to round it off to that second decimal place there. So 6.88. So my height is 6.88. Now if I wanted to figure out the area of one triangle, the area of this triangle, it's going to be 1/2 the base times the height. I know that the height is 6.88 and the base is 10. So it's 1/2 10 times 6.88. If I were to multiply that out, it would be the same as 5 times 6.88 or 10 times 6.8 divided by 2, which is going to be 34.4. That's the area of one triangle. The catch is that I need the area of 5 triangles. That equals 5 times this value here, 34.4. Just to make sure that I'm accurate, I'm going to use the calculator again. So it's going to be 5 times 34.4. That's 172. So it should be about 172 square units. So this is 172. So that means the area of the pentagon with sides 10 feet is 172 feet squared. That was one of the more complex examples because it doesn't easily divide, and we got to do some fancy trig calculations with a calculator here. Let's look at